our topic for today is machine. Okay, so machine has made our life very easy. Okay, now everyone is relying on machine to do their works. Okay, and we all have a common definition for machine, like machine is a device which makes our work easy. Okay, but this definition is not complete for class 10 student. Machine is a device which makes our work easy is a definition for intermediate school students. Okay, they can answer this, but for class 10 students the proper answer will be a machine is a device used to overcome a large resistive force by applying a small force, or to gain speed, or to change the direction and the point of application of force. Okay, so machine is a device which is used to overcome a large force by applying small force. Okay, suppose we are lifting a heavy stone. If you want to lift a heavy stone, we may not be able to lift it directly with our hand. So at that time what we use a crowbar to lift it. Okay, we are reducing the force which is needed to raise that load. Okay, so I'll be explaining this definition slowly. So before that, let us understand few examples of machine. Few examples of machine are, I have given here out here. Crowbar, okay, used to lift heavy loads. Pulley, used to draw water from the well. Pair of scissors, used to cut papers. Jack screw, used to lift the car while changing the tire. A nut cracker, which is used to open the nut. Okay, because it is very hard to open it by hand, almost impossible. Okay, to open it by hand, it's very hard. And it's called shears. Okay, shears, which is used to cut tin, or it is used as a gardening tool also. Okay, there are many more examples of a machine. You can find out some of them. Okay, now next we'll go to the functions of a machine. Okay, what are the functions of a machine? So first function of a machine is to overcome a large resistive force by applying a small force. It's in the definition only. Okay, in the definition it is said a machine is a device used to overcome a large resistive force. Okay, so that is the function only. Look at this, overcome a large resistive force by applying a small force. Look at this example. We cannot lift this load directly, so what we do, we apply small effort out here, with the help of which we can raise this load. Out here we cannot lift car with our hand while changing the tire. It will be extremely difficult for us, so what we do, we use a jack screw, which is a machine, to lift the car, and we can do that by applying small amount of force out here. Okay, next function is to gain speed. Okay, next is to gain speed. So first of all, what is the formula for speed? Speed equals to distance by time. Okay, speed equals to distance by time. Now look at this point. Sorry, wait, look at this point. At this point we apply effort, isn't it? At this point we keep the papers which is needed to be cut. Okay, so this is the distance moved by the effort, this is the distance moved by the load. Both of them takes place in same time, isn't it? So distance moved by the effort and distance in this suppose I will calculate the speed of the effort. Speed of the effort equals to distance moved by the effort by time, and velocity for, or speed for, the load is distance moved by load by time. So which is more, which one is greater? By looking at the example we can clearly say, since the distance moved by the load is more, so the speed of the load is more. Okay, now out here what we can find out, with this small input speed we are getting large output speed. Okay, I'm saying this in a simple way. Okay, which we can say that we are increasing the speed, we are gaining the speed. Okay, small input velocity, large output velocity, so we are gaining the speed. So this pair of scissors is also a machine to gain the speed. Okay, another example of machine which is used to gain the speed is gears. Okay, gear system. Next function is to change the direction of force. Okay, Now look at this, it is a pulley. Suppose this is a bucket full of water which we want to draw from the well. So in which direction we want that water to come? In this direction, isn't it? We want the water out of the well in this direction. But how do we apply force? We apply force in this direction out here. So we are changing the direction of force. Okay. And last function we have to change the point of application of force. To change the point of application of force means we will apply force in one place, but that force will be applicable in another place. For example, let us consider a bicycle. Okay, suppose this is a bicycle and there is a pedal out here and this tire moves with the help of a chain. Okay, we apply the force at this point. We apply the force at this point, but the force will be applied in this rear tire with the help of a chain. So we can change the point of application of force. We are not applying the force directly on the rear wheel, but we are applying the force on the pedal, and that force gets transmitted to the rear wheel. So in this way, in this bicycle, we can change the point of application of force. Okay, these are the 4 functions of a machine. Right. So our next topic will be some technical terms related with the machine. So before understanding about machine, there are many terms in the machine which we need to understand. Okay, the first one is load. So load is that resistive force which we need to overcome. Okay, it is a resistive force which we need to overcome. In this case, a knot, we need to break the knot. Okay, it is a resistive force. This is a load, we need to raise the load. This is also a resistive force. Okay, this is also a resistive force. All right, now next is effort. Okay, now effort is the point where we apply the force to the machine. We apply force to overcome the resistive force. To overcome the force of load, or to overcome the effect of load, we need to apply the force, that is called effort. Okay, next we have mechanical advantage. It is very important. Okay, mechanical advantage is the ratio of load to effort. Mechanical advantage equals to load by effort. Okay, so for example, suppose this is a, wait, suppose this is a load with 80 kgf and I am lifting this load with the help of this crowbar by applying only 20 kg force. Okay, so what will be the mechanical advantage of this rod? Mechanical advantage equals to load by effort. Load by effort, cancel this, we will get 4. So the mechanical advantage is 4. Okay, so what is the unit of mechanical advantage? Mechanical advantage does not have unit because it is the ratio of same physical quantities. Next is velocity ratio. Velocity ratio is the ratio of velocity of effort to the velocity of load. Okay, ratio of velocity of effort to the velocity of load. It also does not have any unit. Okay, and it is also defined as the ratio of distance moved by the effort to the distance moved by the load. We all know the example of scissor. Okay, suppose this is a scissor. So how to find velocity ratio? Distance moved by the effort to the distance moved by the load. So in this way we can find the velocity ratio. Like I said, it does not have any unit because it is the ratio of same physical quantities. This mechanical advantage and velocity ratio is very important. Okay, you will frequently hear this term in this chapter. Next we have input work. Input work means the work which we do to the, which effort does to the machine. Okay, input work means the work which the effort does to the machine. It is also, we can also say in simple language, input work is the energy supplied to the machine. Okay, whatever energy we supply to the machine to overcome the load, that energy supplied is called input work. Okay, it can be written as since work is force into displacement, or to be written effort into effort distance. Okay, next, output work. Output work is the work done by the machine on the load. It is the machine work generated by the machine. Okay, suppose we apply some input work, that input work will be utilized by the machine to do the work on the load. That work which is generated by the machine on the load is called output work. Okay, it's formalized load into distance moved by the load. Alright, now from this what we can say is input work is always greater than output or equal to output. Okay, input cannot be less than output because output work uses the energy of input work, or it uses the energy of effort. Next, efficiency. Efficiency is the ratio of output work to the input work. Okay, to explain it in simple form, what we can say, efficiency means how much input energy the machine can utilize to give the output energy. For example, I'm giving input work of 20 joule and the machine gives the output work of 18 joule. Now, is the machine 100% efficient? No, the machine is not 100% efficient because it is losing 2 joule of energy. Okay, so where does this 2 joule of energy go? This 2 joule of energy is lost in the form of heat because of friction in the machine and because of weight. Okay, so first let me complete this. Efficiency does not have any unit. Okay, efficiency means output work by input work. So generally there are two types of machine. One is ideal machine and one is practical machine or real machine. Okay, ideal machine are those machine which converts all input energy into output energy. Okay, if all input energy is converted into output energy, the machine is called ideal machine. Okay, perfect machine. And if some of the input energy is lost in the form of heat, which happens in reality, that is called real machine or practical machine. An ideal machine is just an imaginary concept. There is no such machine called ideal machine. Okay, because every machine loses some amount of energy in the form of heat because of friction. Okay, so ideal machine is not possible. Next we have principle of a machine. Actually it should be principle of an ideal machine. Okay, so because this principle applies for ideal machine. What does principle of machine state? For an ideal machine, input work equals to output work. Like I said earlier, if all the input energy can be converted into output energy, okay, that machine will have 100% efficiency, and in that case input work is equal to output work. Okay, but for practical machine, input work is not equal to output work. For practical machine, input work is always greater than output work. Okay, so where does some of the energy go? Okay, some of the energy gets lost in the form of heat. This is a most common question from this section. Okay, the question will come like this: is it possible that all the input energy is converted into output energy? No. In another form they can ask like this: is the machine with 100% efficiency possible? No, the machine with 100% efficiency is not possible because some of the energy is lost in the form of heat because of friction of the machine and because of the weight. Okay, now next we have one very important topic: relationship between efficiency, mechanical advantage and velocity ratio. We are finding relationship between efficiency, mechanical advantage and velocity ratio. Okay, so to start with, we'll look at the formula of efficiency. Efficiency is equal to output work by input work. Okay, now we have already done this. What is output work? Output work is load into distance moved by the load, and input work is effort into distance moved by the effort. Now look at this carefully. What is load by effort? Load by effort is mechanical advantage. That's why we get, so in place of this load by effort we write mechanical advantage, and this will take to the denominator out here. This distance moved by the load will take to the denominator, so it will be replaced by 1, and it will go to the denominator out here. Okay, so mechanical advantage into 1 by distance moved by the effort by distance moved by the load. Okay, but what is this effort distance by load distance? What is distance moved by effort by distance moved by load? It is called velocity ratio. 1 is already there out here. In denominator, effort distance by load distance will give us velocity ratio, and mechanical advantage is already there. So our final answer will be efficiency equals to mechanical advantage by velocity ratio. Okay, so what are the important formulas which we have come across till now? Mechanical advantage, load by effort, velocity ratio, distance moved by effort by distance moved by load, and efficiency is output work by input work, and the last one, efficiency is mechanical advantage by velocity ratio. We need to remember these formulas by heart because we have to do numerical, okay, later on, and we need these formulas in the numerical.